Hey, what's up, guys? My name is Saurav, and this is my YouTube channel, Data Science Novice. So, if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So far we have learned how to input images, then we learned how to draw shapes and all that thing. By this time, I'm guessing you guys are comfortable with OpenCV syntax. You have no problem, writing code on your own. From now on, we will learn project specific things. So you might aware of data science that we have a lot of data cleaning process because how good our algorithm works depend upon how good our data is. This is like garbage in and garbage out. Similarly, in computer vision, we have to clean data before running our algorithms. In case of computer vision, the data is image. So now on, we will learn how to clean images for a specific task. And this is request from you guys that please do like and subscribe. It takes a great amount of effort creating these content, and your like and subscribe boost me to create more content. So please do like and subscribe, and if possible, please do share with your friends. So let's get started. So today we are going to talk about blurring and smoothing, and then we see how to apply it using OpenCV, and then we will use a real life example and try to perform some tasks. So a high resolution image or image having lots of detail contains a lots of edges, and this is a problem sometime in edge detection because we end up getting lots of edges, and this is something we don't want. So we will talk about edge detection in later part of the tutorial. So how do we deal with this problem? So we use blurring and smoothing technique to deal with edge detection problem. In blurring, we reduce the edge content and make the transition between one color to another color a lot more smoother. One of the project we are going to do is a Sudoku solver, and in that project we are going to use this technique to detect the edges. And blurring also help reduce noise in the image, and we will be doing that in practical session of blurring and smoothing. So now let's talk about the math behind blurring and smoothing. And for that, I'm going to take help of my website and another website. And the link is in the description. So initially, you might get a little confused, but I would suggest you to read my blog and the website once we are done with the lecture. This will give you a better understanding of what's happening. So here is my blog, and I have written posts on different topics. But today we are going to look into convolutional neural network. And don't worry about it, you don't have to read the whole blog. You just have to read till convolutional layer because the same idea is being used in blurring technique. So here we are in our blog, four layer of convolutional neural network. So if you scroll down, you can find the mathematics behind it and how it works. So let's scroll down and let me show you how it works. So here we have the CNN structure, and here is convolutional layer. So we have actual image, then we have filter, and the filter moves over the image, and this is known as convolutional operation. So let's talk about it in detail. So here I am on the other website. So as we know that we can represent image as a pixel value. So this picture is a face is being represented in form of pixel values. So if you hover your mouse over the pixel matrix, you see a red box on pixel matrix as well as on the image. So this pixel value represents that particular area in the image. So if you move your mouse on the pixel matrix, you can see red box moving on the image as well. So next we are going to talk about filters or kernels. And this kernel can be of any size, but it should be smaller than the image. There are many filters like blurring filters, sharpening filters, and so on and so forth. So if we choose blur filter, we get this kind of matrix. Next, we apply this blurring filter so it moves over the image and does the element wise matrix multiplication. So this 3 cross 3 area information is getting compressed into 1 pixels, and this is known as convolution operation. So this kernel moves over the image and this output image is created just as I told you earlier. So let me show you again. So you can imagine that is a blurring filter, and then we have the image, and then we have output image. So this way convolution operation works. So here again, if I move the filter, we see that red box moving. So that's all. So if you're still confused, I would suggest you to read my blog along with this blog, and it will help you understand better. And if possible, read about neural networks and convolutional neural networks in advance because we will be talking about them in later part of the course. So next we are going to talk about types of blurring filters. So let's move to the slide. Before we talk about filters, I want to make one thing clear. This is not in-depth on blurring. We are just going to learn what it is and the basic idea behind it. If you want to go into the mathematics or into more detail, there are many resources out there. So if you want to explore more on blurring, I would suggest you to read a blog or any book. So the first one we are going to talk about is average blurring. So in this type of blurring, the area under the filter is getting averaged, and then the central element is being replaced, and this keeps happening till the time we get blurred image. And we can do this by using OpenCV. We just call cv2.blur and we pass few parameters that we will learn in later part of the section. So here is an example of 3 by 3 kernel, or you can say filter, that blurs the image. One thing to note that the kernel size should always be odd number. This way we can get the central element. In this case, if you look at this particular example, the central element will be the element at fifth position. Next we have Gaussian blurring. In this case everything is same. Instead we use PDF of normal distribution to estimate the values and then replace everything with the middle value. And this is quite easy, we don't have to do the mathematics. OpenCV does it all for us. So we just have to call cv2.gaussian blur and then we pass few parameters. And we don't have to pass what type of kernel we have to pass. We just have to pass the size and it decide itself. And if you want to if you want to use your own custom kernel, you can create your own custom kernel by calling cv2.gaussian kernels. Next we have median blur. In this blurring we will replace the values by median of that particular area, and this is quite simple. We just have to call cv2.median blur and pass the few parameters. One thing to note that this blurring technique is quite effective when dealing with salt pepper noise, that is image containing noise in form of dots and etc. So that's all for the theory parts. Let's open up the Jupyter notebook. So I have already made the required imports. Next we create a function which I have already talked about why we need it. So we are going to call this function plot underscore image and it takes image as an argument. Next we call plt.figure and set the figure size by 7 by 7. Then calling plt.imShow method and pass the image. So here we have created our function. Next, we upload the image and you can use any image you want. So calling cv2.imRead and passing the file name. Then we have to correct the image from BGR to RGB color channel because we know that how OpenCV works. So calling cv2.cvtcolor and then we pass two arguments. The first is image itself and second the cv2.color underscore BGR to RGB. So next we plot the image, and to do that we call plt underscore image and then we pass the image itself. So here we see that the photo of Albert Einstein. So if you if you look closer to the image, you can see that it contains some noise. It is salt pepper noise that we earlier talked about, and we will use blurring technique to reduce the noise, as well as I will show you how to blur the whole image. So first we are going to do blurring using custom kernels. That is, we are going to create a kernel and then we will use three techniques we talked about earlier. So we create a kernel variable which is equals to np.ones and we pass the kernel size. In this case we are going to pass 4 by 4 and then we divide it by 16. That is basically average blurring filter. So let's check out this kernel. So how it looks like. So here we see that it contains same values. So next we are going to apply this kernel over the image and we have cv2 functionality for that. So we are going to create another variable. We call it new. Then we are going to call cv2.filter2d and it takes few parameters. So the first parameter it takes is image itself. Then we pass desired depth, that is -1. That is basically saying we want the same depth as the original image. And next we pass the kernel itself. So this filter 2D does the convolution operation we talked about earlier, where the filter moves over the image and we get another image as output. So next we are going to plot this image. So let's call our plot function and then we pass the image that is new. So here if we look at the image, the grainy noise or salt pepper noise has been reduced and this new image looks more clear. I don't know whether you are able to tell the difference, but from my screen it looks clear. But don't worry about it. We will be reducing noise on some other images where you will be able to tell the difference. So next we are going to change the filter size and see what happens, whether we see different results or not, that whether we are able to dealt with the noise with the same level or not. So let's change it to 8 by 8, and next we are going to change the division. So here it is going to be 64 instead of 16, because this is a average blurring filter and we have to make sure that we divide it by the total number of boxes. Then we run the cell and let's check the kernel. So here we have bunch of same values. Next we just run the convolution operation. So here the noise is dealt way better than the earlier one, and we are seeing little bit of blurring as well. Next we are going to increase the kernel size by 20 by 20, and then we change the 64 to 400. Now this time we are going to see what happens, and this is going to be really fun. So let's run this up, and now let's run the convolution as well. So here we see that now we are able to see a blurry image. So why this happened? When we increase the kernel size, we saw a blurry image. This is because we try to represent more area with a single pixel. So imagine that 3 by 3 pixel cover a less area, and now imagine 20 by 20 pixel is covering the more area and giving out only 1 pixel value. So higher pixel values are dominating the lower pixel values. This means we are losing noise or we are losing little information, hence we are getting the blurry image. So next we are going to use OpenCV inbuilt function to do the blurring. So before that we have to renew the image, so I'm going to copy paste the image. Next we create a blur variable, then we call cv2.blur and we pass image, and then we pass k size, that is kernel size, and the kernel size is going to be 4 by 4. One thing to remember is that not all blurring filter takes even number, like here I have passed 4. In some filter, if you pass even number for the kernel size, you may get an error. So in those cases, you have to pass an odd number. Next, we call our plot image function and then we pass the blur image. And this looks exactly like the custom kernel blur. So next you can play around with numbers, so you can pass 20. And one thing you will notice that this filter is behaving in the same way as the custom kernel. So next we are going to apply Gaussian blur on the same image. So let's copy paste the same code. So next we create a blur variable, and for Gaussian blur we are going to say cv2.Gaussian blur, and we pass few parameters. So first it takes image, and then we pass the kernel size. In this case we are going to pass 7 by 7, and next we are going to pass variance in x direction and variance in y direction. So if you pass variance in x direction, then it's going to take variance in y direction same as x. So we are just going to pass variance in x direction, and these are the parameter you can play around with it in order to get a better result. So in future we will be doing all these things. Next we use plot function to plot the result. So here we have the results. So here we have the results. So you can compare your result with other filter as well. Try to compare it with average blurring filter. So next we are going to apply median blur, and to do that we are just going to copy paste the same code. So next we create a variable called blur, and then we call cv2.mainBlur, and then we pass two parameters. The first parameter is image itself, and the second parameter is the kernel size. In this case we just have to pass only one value. Next we plot the result by calling our plot function. So here we have the image and here we have the result. So let's change the kernel size and see what happens. So you can see that now this image look more smoother than the previous one. So this way we can use all the three blurring filter to make the image look more smoother. And now we are going to use an image which has lots of noise. You can say salt pepper noise, and we will use blurring technique to reduce the noise as much as possible. So let me copy paste the code, then I'm going to change the file name. So you can use any image. So once you see the image, just try to find any image on the internet that looks like this image. Or and next we call our plot function to plot the image. So here we have the image of Charlie Chaplin, which has lots of dotted noise. This is called the salt pepper noise. So we will try to reduce the noise. We will try to see that how much noise we can reduce. And to do that, we will be using median blur, because median blur is very good with salt pepper noise. So we call blur is equals to cv2 dot median, and then we pass the image, and next we are going to pass a kernel size of 5. So next we call our plot function and we plot the result. Oops, we have an error, so let me correct it and then we will run it again. So here we have the image and you can compare both the image. Our second image looks much more better than the original one. Now I would suggest you to try all the other blurring filter. So that's all for this video. And if you haven't subscribed my YouTube channel, please do like and subscribe to my YouTube channel and press the bell icon for the future updates. Till then, bye, stay safe.